Hello everyone, it's my great honor to have the opportunity to give a report at this conference. My name is R2 Yuanzhang. I'm a PhD student from Southeast University. Currently, I'm doing some research on concrete durability. Today, my topic is the competitive diffusion process of chloride into mortar immersed in chloride and sulfate solution. My report have 4 parts. The ingress of chloride into concrete object results in reinforced cement corrosion, which has become a worldwide problem in the past few decades. So far, a large number of the studies have focused on the chloride transportation and the binding mechanism. Also, the Ficker's second law have some limitation to describe the chloride diffusion process. The error is still acceptable. There are 2 important parameters in Ficker's second law: chloride diffusion coefficient and surface chloride concentration. In addition, the chloride bindings can effectively delay the transport process. There are several binding curves to describe the relationship between the free chloride and the total chloride. As we all know, chloride ions are not the only ions in seawater. There are also some other ions. As shown in the figure, the anions in seawater, sulfate ions are the second only to chloride ions. According to the existing conclusion, the presence of the sulfate will affect the chloride transportation and the binding mechanism. For example, sulfate ions can release the bound chlorides, which will accelerate chloride diffusion. Therefore, there has been a lot of the research focusing on chloride-sulfate solution. The existing conclusion and theoretical analysis have proved that the concentration is very important for chloride attacks. However, there's no uniform definition on salt solution concentration ranges. My report today is about the chlorides and sulfate concentration. In order to get a continuous result, mini table is used to design the salt solution. For the salt solution, the concentration of the chloride is 0 to 25%, and the sulfate is 0 to 5%. The specimen was sealed with the exposure on around to ensure the one-dimensional diffusion, and the test including chloride diffusion depths, the chloride profiles, and the XRD-SEM analysis. As the result of the diffusion depths shown, the diffusion depth in chloride solution was shorter than that in compound salt solution before 120 days. After that, the diffusion depth in chloride sulfate solution was less than that in single chloride solution. In addition, the total chloride profiles has a similar formula. The 2 results show that the sulfate's effect on chloride diffusion are time-dependent. Continuous results can reflect the interaction between chloride and sulfates. As we can see, the concentrations has a bigger effect on chloride profiles. The higher chloride salt concentration, the greater amount of chloride ions going to the mortar. The effect of sulfate is also concentration dependent. In order to establish a chloride diffusion equation, the diffusion coefficient is obtained by the least square method, and the data from the total chloride profiles. The surface chloride concentration is related to salt concentration and the exposure times. The function expression has 3 types, and the pole function is the best. Therefore, chloride ions diffusion equation considering salt concentration and time is established, which is in good agreement with the experimental results. There are 2 kinds of the hydration products that can bind the chloride ions, the CSH phase and the AFM phase. From the XRD analysis, when immersed in chloride and sulfate solution for 60 days, phase salts will still appear at the outermost layer. However, it disappears after 210 days, which is because of the sulfate attacks. So the sulfate can replace phase salt to form nitrogens. There was a large amount of sodium chloride crystal in the mortar, as determined by the EDS analysis. From the total chloride ions in the mortars, most of them are free chloride ions. The nitrogens crystal has been found in the pore. It can be inferred that the presence of the sulfates will change the pore structure. The last part is the conclusion. First, the influence of sulfates on the chloride diffusion depends on not only the exposure times but also the concentration. The stable bond chloride is susceptible to the sulfate chlorides. So the presence of the sulfates will promote the chlorides at the earlier exposure. Third, the RTZ and the pore are the main paths for the chloride sulfate diffusion. The formation of the nitrogens and gypsum caused by the sulfate attack will delay the chloride diffusion in the long term. Thank you again. My report is over.